Welcome to the lesson on congruence of triangles. At the end of this lesson, you will be able to define the congruence of triangles and state the criteria for the congruence of two triangles. Let's discuss the congruence of triangles. Consider two triangles ABC and XYZ such that the corresponding angles are equal. And corresponding sides of both the triangles are equal. Here you see that the sides of triangle ABC coincide with the sides of triangle XYZ. The angles of triangle ABC cover the angles of triangle XYZ. So we can say that the triangles are congruent, and they are denoted by the symbol. Here, the tilde symbol represents that the triangles are the same in shape, and the equal symbol represents that the triangles are equal in size. In general, two triangles are congruent if all the sides and all the angles of one triangle are equal to the corresponding sides and angles of the other triangle. Here, triangle ABC is congruent to triangle XYZ. This also means A corresponds to X, B corresponds to Y, and C corresponds to Z. For any two congruent triangles, the corresponding parts are equal, and it is termed as the corresponding parts of a congruent triangle, or CPCT. Based on the above discussion, we conclude that triangle ABC is congruent to triangle XYZ. But triangle ABC is not congruent to triangle YZX. Congruence of two triangles is defined based on different criteria. We know that two triangles are congruent if all the 6 parts of one triangle are equal to the corresponding 6 parts of the other triangle. You can also prove two triangles are congruent even if the 3 parts of one triangle is equal to the corresponding parts of the other triangle. We'll discuss the basic 4 criteria that state two triangles are congruent. Let's begin with the side-angle-side congruence rule. Two triangles are congruent if two sides and the included angle of one triangle are equal to the corresponding 2 sides and the included angle of the other triangle. This criterion is referred to as the side-angle-side or Sas Congruence Rule. Consider triangles ABC and XYZ such that side AB is equal to side XY, side BC is equal to side YZ, and angle B is equal to angle Y. Then triangle ABC is congruent to triangle XYZ. It is true for the congruent triangles if their corresponding 2 sides and the included angles are equal. It is considered to be an axiom. Next, the second congruence rule states that two triangles are congruent if 2 angles and the included side of one triangle are equal to the 2 angles and the included side of the other triangle. This is referred to as the angle-side angle or ASA congruence rule. Let's prove it. Consider two triangles ABC and XYZ such that angle B is equal to angle Y, angle C is equal to angle Z, and BC is equal to YZ. To prove these triangles are congruent, we use the Sas Congruence Rule. In this situation, you may encounter three cases. AB is equal to xy, AB is greater than xy, and AB is lesser than xy. Let's start with case 1, where AB is equal to xy. In triangles ABC and XYZ, you see AB is equal to xy, angle B is equal to angle y, and BC is equal to yz. This data satisfies the Sas Congruence Rule. Therefore, triangle ABC is congruent to triangle XYZ. In the second case, let's assume that AB is greater than xy. Consider a point P on AB such that BP is equal to xy. Now, in triangles PBC and XYZ, PB is equal to xy, angle B is equal to angle y, and BC is equal to yz. Thus, by Sas axiom, triangle PBC is congruent to triangle XYZ. Since corresponding parts of congruent triangles are equal, thus angle PCB is equal to angle XZY. We are given that angle ACB is equal to angle XZY. So, angle ACB is equal to angle PCB. This is possible only if P coincides with A. So AB is equal to PB. But we have assumed that PB is equal to xy. This implies that AB is equal to xy. Also, angle B is equal to angle y, and BC is equal to yz. Therefore, by the Sas Congruence Rule, triangle ABC is congruent to triangle XYZ. Lastly, consider AB is less than xy. In this case, consider a point Q on xy such that QY is equal to AB. Proceeding the same way as we did in case 2, we can conclude that QY is equal to xy. Therefore, by the Sas Congruence Rule, triangle ABC is congruent to triangle XYZ. We know that the sum of the three angles of a triangle is 180 degrees. If two angles of one triangle are equal to the corresponding two angles of another triangle, then the third angles of both the triangles will also be equal. Thus, instead of the included side, we may have any pair of corresponding sides equal. Thus, the Asa Congruence Rule is sometimes referred as AAS or SAA Congruence Rule. Since this result has been proved, it is considered a theorem. Two triangles are congruent if three sides of one triangle are equal to three sides of another triangle. This is referred to as the side-side-side or SSS Congruence Rule. This can only be proved by construction. Consider triangle ABC. We'll now construct triangle XYZ by using the sides of triangle ABC. On comparing, we see that the respective sides are equal. Therefore, the triangles are congruent. Two right-angled triangles are congruent if the hypotenuse and a side of one triangle are equal to the hypotenuse and the corresponding side of the other triangle. This is referred to as the right-angled hypotenuse side or Rhs Congruence Rule. This rule is applicable only for the right-angled triangles, while the rules studied so far are applicable for any triangles. As you've seen, we say two triangles are congruent if at least three parts of one triangle are equal to the corresponding three parts of the other triangle. But this is not always true. For example, side-side angle or SSA. angle side-side or ASS and angle-angle-angle or AAA are not sufficient to prove the congruence of two triangles. Let's look at some examples to understand it better. Consider two triangles ABC and XYZ, where AB is equal to XY, BC is equal to YZ, and angle C is equal to angle X. Can you superimpose these triangles? This is not possible. Hence, the triangles are not congruent. Therefore, side-side angle criterion does not hold true. Now, let's take an example to examine AAA criteria. Let's look at the triangles. In these, the corresponding angles are equal. Here, the sides of one triangle are not equal to the sides of the other triangle. Therefore, these triangles are not congruent. Let's recap. Two triangles are congruent if the sides and angles of one triangle are equal to the corresponding sides and angles of the other triangle. There is a 1-to-1 correspondence between the vertices of two congruent triangles ABC and XYZ such that A corresponds to X, B to Y, and C to Z. Two triangles are congruent if two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of the other triangle. It is referred as side-angle-side or Sas Congruence Rule. Two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle. It is referred as angle-side-angle or Asa Congruence Rule. Two triangles are congruent if three sides of one triangle are equal to three sides of the other triangle. This is referred as side-side-side or SSS Congruence Rule. Two right-angle triangles are congruent if the hypotenuse and a side of one triangle are equal to the hypotenuse and the corresponding side of the other triangle. This is referred as right-angle hypotenuse side or Rhs Congruence Rule.